Okay, so this is module 3 for Finance 324, the assignment. So this is just going to be going over the homework. With a lot of these, there may not be as much explanation, but I will show the solution set so you can pause the video and watch it and read over it and take notes. So this first problem, we have different probabilities and different holding period returns. So this is what the question is asking for. And then to calculate, they do give you the equations, but here's how to actually calculate that. As you see, it's just the probability times returns for expected return, and then the difference between that return and expected return to calculate our variance and standard deviation. 5.2 is also a problem where we're looking to calculate what the expected return is and then what the standard deviation is. These were all equally likely, so the probability is 1/3 for each. That's why you see the probability of 1/3 in here. They're all equally likely. All right, this one, there's a few different sections. So arithmetic returns, that's where you add them up and divide by the number. Geometric is 1 plus that return. Then you multiply those, and then you take the nth root, however many you had. So here's how to work through that. It's 1 plus the rate for geometric mean, multiply those together. There's 3 of them, so you take the third root. For arithmetic, you add them up and divide by 3. So this problem that they ask you to go and pull up a table, so I've placed it in here as well. And then calculating the holding period return. So this problem, they give us two possible outcomes with equal probabilities of 1/2, or we could just get the 4% T-bill. And here's how we work through that. This one is also having a risky portfolio with a T-bill rate. That's our risk-free rate again. But we're putting some of our portfolio, some of our money into that risky portfolio, and then some of it in the T-bill fund. This one is again very similar. Here's the way we work through that. Just remember, whenever you see the T-bills, we're using that as our risk-free rate. So anytime where there is not, we don't have the risk with that portion, but we still have the risk with the rest of the portfolio. Okay, and here's what we're trying to do. We have a standard deviation of this portfolio of 39%. We're trying to knock it down to only 30% by using the T-bills, which again, that's the risk-free. So the way we would work through it is here. We're just trying to get that 39% down to a 30%. So this much is in the risky. So obviously you're putting the risk in the risk-free, and this is our expected return. And this one is actually already has the answer down here to show how you can calculate that given the information presented. And this is the same in 510. All the information is already here. Remember, the Sharpe ratio is just the risk premium divided by the standard deviation of that risk, or the standard deviation of the portfolio return, which is our measure of risk. So that's why I say reward to volatility. The reward is your excess return. And then the volatility is that measure of noise. And that's all of chapter 5. This module also has chapters 6 and 7. So chapter 6. So no, beta of 1 is the would be like as the market. So anything greater than 1 is more than the market. Here's how we'd work through those problems. Okay, here's problem number 2. They're giving us these different probabilities of these states. They tell us what the returns are for the stock and the bond funds. Right, so we're going to just calculate these. And so just probability times the rate of return, right, to get this one. And then how far is this expected return from each of those? That's what this is, the deviation. Okay, you square that. You take this squared deviation times the probability that we're in each of those states to get this, add those up. That's the variance. The square root of variance is standard deviation. And then you see down here how we can go from the returns on the stock and return on bonds to get what the covariance is. And here's 3 again. There's probabilities of these states, and here's those returns. And here's how we would calculate those again, explaining how to work through those. Okay, 4, 5, 6, and 7 all rely on this information. So again, feel free to pause and come back if you need to go back and look at these numbers. But they tell us expected return, standard deviations, and the correlation between them. And then we also have a risk-free rate of 5.5. So the first bit here in 4, here's how to also calculate that. Just remember, all we're doing is calculating what is the minimum variance portfolio. So this is the safest. You could think of it that way. Here is 5. And 6. And 7. So here's the problem on 7. And here's the answer. So remember, a lot of this, we already calculated those portfolios, but then here's how to get the cal. There's also a spreadsheet specifically for this problem that's posted. Okay, here's problem 8 and its answer. This is a correlation in -1, so they're perfectly negatively correlated. So that would allow you to get that risk-free rate. Here's 9. Here's 10. Right, so we're just getting these expected rate of return. As that the beta is changing. Or no, the beta stays the same. The market return is lower than expected. I know there's a lot to 11 here, so these are all the different sections on that one. This is the one of the 2 homes. First it's 1 home, and then 2 homes, and then 2 investors investing in the property. So there's the setup for the problem, but then here is the answers, right? And so all we're doing is saying there's some probability that this happens, and then some probability that the other thing happens. Just know with two homes, there could be no fires, there could be just one for the first home, there could be one for the second home, or they could both catch fire. So that just makes it a little more complicated as you're working through it, but that's all we're doing is just demonstrating risk pooling and risk sharing. And this is it for chapter 6. Here's chapter 7. So here's two companies. They told us the risk-free rate. They tell us what the market risk premium is, right? So then we can back out what the rest of these look like, because we have our beta, we have the forecast returns, so we have everything we need to be able to calculate what those expected returns would be under CAPM, like assuming CAPM holds, right? So that's this formula. Okay, so here's problem 2. There's 3 different questions that it's asking about this, calculating a beta, the rate of return, and then what the alpha would be. And here's how we calculate those. And if you notice, the alpha ends up being negative in those 2 cases. With the numbers they gave me, that just means that it's underperforming whenever you see a negative alpha. Okay, here's 3, and we actually have the answer on the same page. All right, so again, we're going to get expected return. They tell us what let's see, we have the risk-free rate, the market rate, and then what we have, right, our beta is 0.7, right? So we should be getting 14.5, but we're actually only getting 12. So you see 4 is just using that same CAPM type model. Here's 5. You notice down here is the dividend discount model that they're using. So they're just going back to figure out what that discount would have been. And then if you use a discount rate that goes from 8% to 12%, it changes the value of the stock. Here's 7. Oh, that's 6. This is 7. Sorry. Then this one is 8. And what they've done is they said, instead of just having beta, let's, turn that into 2 different measures. And so that's what we end up doing, is trying to figure out what these 2 different betas would be. One for some set of economic factors and some for a different set of economic factors, right? So later when we talk about Fama French, and the 4-factor, 5-factor, 6-factor models and those types of things, that's what this is setting up for us later. Right. And again, this one says the economy has only 1 factor, beta. Normally with beta, what we're saying is, this is like the risk relative to the market. But you could have other measures. We just want to bring that up to set that up for later. Okay, so this one, this is the setup for it. So to calculate the expected profit and the standard deviation, here's how we set those up. So I know there's a bit of verbiage, but hopefully you understand the return at some time t is equal to the alpha of that investment plus the beta of that particular investment times the return on the market risk premium here, plus some secondary factor times its return, and then some error, some noise that'll be in the system, right? So So we just set all that up. We have our different measures. Calculate that. Okay, and this is the last one that it sets up. If a zero beta, you expect to get the risk-free rate of return. If you have a beta of 1, you expect to get the market, rate of return. So then they give you some other betas that we can put in. A negative beta would be less than the risk-free rate. And here's how we calculate those. All right, and then that will conclude all of chapter 3, or module 3, chapters 5, 6, and 7.